let's find the intervals of increasing, decreasing for the function f at x is equal to x cubed over x fourth minus 18x squared plus 81. We saw in a previous tutorial that this is an easy trinomial and can factor in the bottom to x squared minus 9 squared. That's going to be a little bit nicer to take the derivative of because there's less terms. To find the critical numbers, we've got to take the derivative, set it equal to 0, and solve. So to take the derivative, you can see you require product rule. So I like to do that off to the side. F for the top function is x cubed, and g, the bottom function, is x squared minus 9 squared. To take the derivative of the top, it's simply 3x squared, but on the bottom, g prime, you can see that it's chain rule. So because we have a function within a function. So the outside function is this 2 here, or this x squared, this big x squared. So we'll throw the 2 out front. We'll keep the inside the same, so we take the derivative of the outside function, and we keep the inside the same, so 1 off the exponent. And then we multiply by the derivative of the inside, so that's going to be 2x. And I'll clean that up over here, which is 4x times x squared minus 9. So then the derivative is going to be equal to f prime g, so 3x squared, times x squared minus 9 squared, minus g prime f, so minus 4x x squared minus 9, times f, which is x cubed. And that's all over x squared minus 9, now to the fourth, because we squared the denominator. Okay, so let's clean up a little bit up top. We can see that this one doesn't clean up any more nicely. This one here, though, can become 4x, whoops, that's my fault, 4x fourth times x squared minus 9. And I'm missing a squared here. And that's all over x squared minus 9 to the exponent 4. Okay, so we can clean up the top by factoring. You can see that we have an x squared in common from the x function, and we have an x squared minus 9 to the exponent 1 in common. What are we left with? We're left with a 3 bracket x squared minus 9 from the first one. And then when we common an x squared out of this, we still have the minus 4, but an x squared now. And then the x squared minus 9 has been factored out. So we have that all over x squared minus 9 to the exponent 4. You can see that we can cancel out an x squared minus 9 here, leaving us with an x squared minus 9 cubed on the bottom. And so finally, for our first derivative, we're going to get x squared, and then we had 3x squared minus 4x squared, so that's going to be negative x squared. And then 3 times negative 9 is negative 27. And so that's all over x squared minus 9, which is now cubed. And we can clean it up a little bit more. We'll factor out that negative out of the brackets. So we're left with an x squared plus 27. That makes it look a little bit better. And that's still over x squared minus 9 cubed. Okay, we still have to set this equal to 0 and solve. So if we set this equal to 0 and solve, of course the x squared minus 9 cubed doesn't matter. That's part of our restrictions or our vertical asymptotes. So the only solution that we get from the top is actually x equals to 0. It's the only one, because x squared plus 27, when you set that equal to 0, you won't be able to take the square root of a negative, right? Because x squared equals negative 27 would be your path to solution there. So the only critical value is x is equal to 0. Okay, so now that we know that the critical value is 0, and we know that the vertical asymptotes are 3 and negative 3, we can see that from the bottom, but we also did it in a previous tutorial. We can plot this on a number line, so plot the domain on a number line. That's for step 2. Oops, sorry, wrong color. Okay, so that we have, on the number line, we have that the vertical asymptotes are negative 3 and 3, and we have a critical value at 0. So you can see that for the intervals, it's going to be negative infinity to negative 3. So from all the way to the left up to negative 3, then negative 3 to 0, then 0 to 3, and then 3 to infinity. So we need to take, for step 3, we take test values from within each interval and sub that into for f prime, or the first derivative. So for the interval negative infinity to negative 3, let's choose negative 4. For negative 3 to 0, let's choose negative 1. For this one, we'll choose 1. And for this one, let's choose 4. Okay, so what we're going to do is we'll sub negative 4 into here. So f at negative 4, f prime at negative 4 is going to be negative bracket negative 4 squared. Then we have negative 4 squared plus 27 all over negative 4 squared minus 9 cubed. Now remember that we only really care about whether the answer is going to be positive or negative. So from here we can see that the negative 4 squared is going to generate a positive. Out front of that we have a negative. Then in here, no matter what we put in is going to be a positive because negative 4 squared is positive and we add 27. So we get a positive in here. So you can actually see that on the top, no matter what, we'll get a negative. On the bottom, though, it varies. So for now, when we plug in negative 4 squared is 16. 16 minus 9 is 7. And then 7 cubed is going to be a positive number. So then we have a negative divided by a positive. So we get a negative for f prime at negative 4. That means that it's going to be decreasing over the interval negative infinity to negative 3. But let's continue and sub in the rest of the test values. So when we sub in negative 1, again, we'll have a negative, positive up top. But on the bottom, you're going to get a negative 1 squared, which is 1. Minus 9 is negative 8. Then we're going to cube it, so it's going to become a negative. So, let's get a negative on the bottom. So in total, when you work all this out, you're going to get a positive. So that means on this interval, it's increasing. When we do f prime at 1, it's going to be the same situation as f. This should have been an f prime. It's going to be the same situation as 1. So we're going to get a positive for this one. And when you sub in 4, because we're squaring where we're subbing it in, the 4 is going to be the same as negative 4. So we get this. So therefore, what we know is that it's increasing from negative 4, it's going to be increasing from negative infinity to negative 3, union with 3 to infinity. And then we're going to be decreasing from negative 3 to 0, union with 0 to 3. And that's it. I do a dance of victory, 'cause now I'm living good. No, I'm not living like I used to be. Now talk about things, talk about my mind.